All right, so in this lesson, we're going to do a couple of things. We're going to be plotting our gradient descent path on our 3D surface so we can see our algorithm slowly working its way down to the bottom of the ball. But this is also a really good opportunity to learn a little bit more about NumPy's n-dimensional arrays, because these things are incredibly powerful. And we're going to be taking a look at how we can append values to arrays, how we can concatenate arrays, how we can slice arrays, and how we can select particular columns of an array. So let's commemorate the upcoming topics with a new section heading. So I'm going to change the cell to Markdown, and then I'm going to put 2 pound symbols here, and then I'll write graphing 3D gradient descent and advanced NumPy arrays. And I'll hit Shift Enter. I'm also going to add a few more cells to the bottom, so that way I'm working more in the center of the screen. Now, to do our plotting, what we're going to do is we're going to scroll a little bit up, and we're going to copy this cell here. I'm going to copy the cell, and I'm going to paste this cell here. And the reason I'm doing this is so that I can add some code to it. I want to modify this cell so we have a record of what we've been doing, but this is also the cell which is going to contain the code that tracks the progress of our gradient descent. So I'm going to add some code to this. Now, as before, the values that we're going to be tracking are how our parameters change as the loop runs. And the place I'm going to store all these values that we're going to be tracking is going to be a variable that I'm going to call values underscore array. And the very first value this values array is going to have is going to consist of our initial guess, our params. So leaving the code like this, let's take a really quick look at the shape of our values array. So I'm going to print values underscore array.shape and see what I get. The result's going to be the very first line that's printed below the cell. So I can see that this is a tuple, and my array just consists of 2 elements. And that's no surprise. Those elements are going to be 1.8 and 1.0. And that's all this shape attribute is showing us. Now the thing is, I can transform this array if I want to. Instead of having a one-dimensional array with 2 elements, I can have a 2-dimensional array with 1 element each instead. But why would I want 2 dimensions? Well, what I want to do is I want to keep all the x values in 1 dimension, and then I want to keep all the y values in the 2nd dimension. So what I'm going to do is I'm going to transform my array into a new shape. So handily, there is something called a reshape method, which takes 2 inputs. One is the number of rows, and the other is the number of columns. So rows are first, so it's going to be 1, 2. Those are going to be the arguments to the reshape method. Now if I rerun the cell, have a look at the output below the cell to see how many rows and how many columns my array has now. So you should see this updated to 1, 2, so 1 row, 2 columns. I now have a 2-dimensional array. My x value is going to be in my 1st dimension, and my y value is going to be in my 2nd dimension. Okay, yeah, so you might say, yeah, Philip, great preamble, but where are you going with this? And what I would say to that is, I'm setting the scene for the code I'm going to add to my for loop right here. But before I do that and move on to the code inside the gradient descent, let me add a new cell below this one and just go through a few methods and a few techniques for working with multidimensional arrays. So I'm going to add a little comment here. I'm going to call this advanced NumPy array practice. And the first thing I'm going to do, of course, is create a dummy array. this array is going to have a name. It's going to be called Kirk, and it's going to be equal to np.array. So we're creating an array, parentheses, and then I want this array to have one row and two columns. So I'm going to have one square bracket, and then a second square bracket, and inside I'm going to put a string. I'm going to say captain, and then comma, and then I'm going to have another string, and that's going to read guitar. So two strings surrounded by two square brackets. So just to verify that we indeed have a two-dimensional array, let's print out Kirk.shape below the cell and hit Shift Enter. There we see that we have one row and two columns by using this notation here. All right, so upwards and onwards. This time we're going to create a 2 by 2 array. So this is going to be 2 rows, 2 columns. And I'm going to call this array hs_band. I'm going to set it to equal to np.array, parentheses, and then I'm going to add 2 square brackets again. And inside the second square bracket, I'm going to add a string and call it black space thought. And then after the string, I'm going to add a comma, and then another string, MC. And then after that first closing square bracket, I'm going to add another comma, and then I'm going to open another square bracket and add the string Questlove, comma, and then the string drums. And then you'll have 2 square brackets at the end and the parentheses. So this is our second array. And let's print out the shape. So print hs_band.shape. And here we can see that indeed this array is 2 by 2, 2 rows, 2 columns. Now when working with multi-dimensional arrays like this, let me ask you a question. How do you think we would go about selecting a particular item in the array? So previously we just used the square bracket notation and then we supplied an index. Let's see what happens when we do that on a two-dimensional array. So I'll say print, and I'll just put down in the string the code I'm going to add after the string. So I'm going to say hs_band square bracket 0, and then after the string I'm going to add a comma and then put the actual Python code here, hs_band square bracket 0. I'm going to hit Shift Enter here. So we can see here that if I use the very, very same approach with a two-dimensional array for selecting a particular item as with a one-dimensional array, I don't get back one item. Instead, I'm getting back an entire row. I'm getting back all the elements in that first row. But the thing is, that kind of makes sense, right? We have 2 dimensions, so we shouldn't be supplying one index. We should be supplying 2 indices. How do we do that? Let me just copy this line of Python code here, add the print statement, paste the print statement below, and then instead of having just hs_band square brackets 0, I'm going to add another pair of square brackets here. And between those, I'm going to put the value 1. I'm going to add that to my string as well so that we're consistent. And I'm going to hit Shift Enter. And what you should see is that in this case, we're selecting one particular element. We're selecting the first row and then the first column in that row. So we're honing in on the string MC. Now, if you have trouble seeing this in your print statements, then you can put a few spaces here and a semicolon. Might make it a little easier. And then you'll have a nice separation between the string and the value that you're getting back with your Python code. All right, so this was already one difference between working with a one-dimensional array and a two-dimensional array. Now, as a challenge, can you modify this print statement to select the word Questlove and have that printed out right here where it says MC currently? I'll give you a few seconds to pause the video and give this a shot. So I hope you had a chance to solve this. Questlove is in the second row. So we start counting at 0. Second row is at index 1. And it is the first item in the second row. So first column. So this would be column 0. Let me hit Shift Enter, prove to you that this is indeed the case. And there we go. We see Questlove printed out below. Now let's create another array, but through a different way. I'm going to call this array the underscore roots. I'm going to set it equal to np dot append. So I'm not going to write np dot array. I'm going to write np dot append. I'm going to open the parentheses, and inside these parentheses, I'm going to supply 3 arguments, 3 inputs. The first argument is going to be the array I want to append items to. This is going to be arr equals hs underscore band. I'm going to put a comma and supply my second argument. And these are going to be the values. So I'm going to write values equals Kirk. And then I'm going to supply the third argument. And this is going to be the axis. And the axis is going to be equal to 0. And below all this, I'm going to add a print statement. So I'm going to say print the underscore roots. Now, before I hit Shift Enter, I'm going to make sure my variable names are the same. So this is going to be the roots is equal to np.append arr equals hs underscore band, comma, values equals Kirk, comma, axis equals 0. And then I'm indeed printing this variable here, printing the roots. Now let me hit Shift Enter so you can see what this looks like. Now what we've got is that below the cell, there are 6 elements being printed out. We've got the 4 elements from HS band, and we've appended 2 extra elements, namely captain and guitar, to these 4 elements. So our array called the roots is actually 3 by 2. It's a 3 by 2 array. Now let's take a look at this append method. The append method takes 3 arguments. The first one is, the element where the items are going to be appended to. And the second argument here is our array, which was appended to hs underscore band. And then we've got this third argument here, axis. Axis equals 0. And the first time I saw this, I thought, man, this is a really confusing word. But it's actually pretty simple. Axis basically means, should we add our values as a row, or should we add them as a column? So what we've done is we said axis equals 0, and that means that our values inside Kirk are added as a row onto our 2 by 2 array. So our 2 by 2 array became a 3 by 2 array. If axis instead was equal to 1, then we would be trying to add our new values as a column. But you have to be careful with these axes. If you try to change this to 1 and press Shift Enter, it actually won't work because Kirk is actually a 1 by 2 array and not a 2 by 1 array. So you have to be careful because your axes have to match. You can't add up or append items to arrays where the dimensions don't match. Kirk has 1 row, 2 columns, and you can't add a 1 row, 2 columns as columns to a 2 by 2. If you actually wanted to do that, you'd have to reshape the Kirk array to be 2 by 1. This is the only way it would work. In this case, you would indeed get a 2 by 3 matrix, a 2 by 3 array. So I hope this makes sense. If you're appending stuff to an existing array, then the shapes of the array have to be compatible. So in this case, what I actually want to do is I want to add rows on to my existing array. So I'm going to say axis is equal to 0, and the way I've made these arrays, the rows already match. So I'm going to hit Shift Enter again. So you refresh this and you can see indeed, okay, I've got an artist and I've got a role in the band, and here's another artist and here's another role in the band, and so on. Now, I'm not going to make you add all the band members of the roots individually. That would be very, very time consuming. But let's just pretend this band has 3 members for now. And suppose that we want to select all the band members just by their nicknames. So we want to just take an entire column from this array. How would we do that? And the answer is that this is actually really, really, really easy to do with some special Python notation for slicing arrays. Let me show you. If I print out and I add a string here, printing nicknames, ... comma, and here's how we slice our array. Here's how we only print out the first column. We're going to say the underscore roots, square brackets, and we're going to supply 2 values. The first one is going to be a colon, and then we're going to have a comma, and then we're going to have a 0. So what we're saying here is to take all the rows. So a colon is the shorthand notation here for selecting all the rows, all the values in the rows. And that second argument here, that 0, refers to the first column. Let me hit Shift Enter, show you what I mean. I'm going to scroll down, and there you should see printing nicknames, Black Thought, Questlove, and Captain. All right, so let's practice this one more time. I'm going to add another band member though. So I'm going to say the underscore roots. I'm going to update our roots array with np.append, and for the array I'm going to choose the underscore roots, and for the values I'm going to say values is equal to double square brackets. So I'm going to add the values here directly, and then between those square brackets I'm going to provide 2 strings. The first one is going to say Malik space B, and then comma, single quotes, MC. Closing square brackets, comma, axis again is equal to 0. Having added another band member here, let's print out the roles. So I'm going to say printing band roles, ... and then after the string, put a comma, and now I'm going to throw the ball over into your code. I'm going to challenge you to print out all the band roles in the roots. So I'm going to give you a few seconds to pause the video and write the Python code that will print out all the band members' roles below the cell. And here's the solution. Again, we're going to use our array slicing notation. So I'm going to say the underscore roots, square brackets, colon, comma, 1. When I hit Shift Enter, I can see now that we've got 2 MCs, 1 set of drums, and 1 guitar. All right, so with these array techniques covered, we're ready to move on to graphing our gradient descent. And if you haven't heard of the Roots, then check out a song of theirs called The Next Movement. That's one of my personal favorites. A long time ago, I actually went to see these guys live. They came down to London. And I think one of the things that impressed me most was that during the performance, the band members traded the instruments. So like the drummer took the guitar, and the guitarist took the vocals, and the vocalist took the bass, and so on. And having done that, they proceeded to play their next song, just showing everyone in the audience that they weren't one-trick ponies, but actual musicians who could do more than one thing. I mean, I haven't gone to that many concerts, but I've never seen that before. So yeah, check out these guys. They're pretty cool.